I can.
I can. I believe that's Walter, right?
Oh yeah.
Oh yeah. Okay. So let's go. So how are you gonna do this one?
Alright, so first you're gonna make a little inequality. Because 120 is bigger than 90 degrees, you know that z plus 23 is greater than 3z plus 9.
Okay.
And then you're gonna do some twing twacks. So you're gonna subtract 9 for both sides.
Okay.
And you get z plus 14 is greater than 3z. And then you subtract z from both sides, and you get 14 is greater than 2z. And then you divide by 2 and get z is less than 7. And then because those two sides, the a to the middle point thingy, and then the middle point thingy to c, it doesn't have a name. We can call it d, I guess.
So we're looking at 3z plus 9. What has to be true of 3z plus 9?
It's greater than 0.
It's got to be greater than 0, right? So we can do the same thing. So we know 0 is less than 3z plus 9 minus 9.
Or 0 is just, z is greater than 0.
Wait, I thought z is greater than -3.
Well, you can't have a negative side length.
But you can have, but if we have -1 for z, 3 times -1 is -3. -3 plus 9 is still a positive, right? So z can be negative, but the side length cannot. So divide both sides by 3. 1009.
So z has to be greater than -3.
Right. All right, so how about this two-column proof? Two-column proof. Can I have a different volunteer? Do you want to do this?
Sure.
Okay, so Claire said sure.
So first you can just write the given. So it says xy is congruent to wz, and then xw is greater than yz. Wait, okay, so if xw is greater than yz, then I think that means that angle xyw is greater than angle wyz.
But we have to do one step before we do that, because so you're talking about the hinge theorem, and the hinge theorem requires you to have two congruent side lengths and an angle that's adjacent.
The reflexive property, so wy is congruent to wy.
Okay.
And then angle xyw is greater than angle wyz.
Okay. Are there questions on that one so far? So definitely, okay. So we're going to take a look at 1 and 2, and then I'm going to stop the video, send it up to YouTube, and then I want you to do 3, 4, 5, 6, and 7. All right. So simplest radical form, again, is a way of showing an exact answer. Now, decimal equivalents are very, very good. They're excellent. They're super close. But if you ever needed an exact answer, you'd have to keep the square root around. So when you are taking or finding the simplest radical form, we need to find the number or a factor that is a perfect square. So is there a factor you can think of that's a perfect square of 216?
Does 9 go into it?
9 does go into it, yes. Okay, so we can do the square root of 9. And you knew it went into it because 216, 216, you add them together and the sum of the digits is 9, so it's divisible by 9. So 9 goes into 21 twice, carry the, so that's a 3, so 9 goes into 36 4 times. All right, what is the square root of 9?
3. Yeah.
What is the square root of 24?
The square root of 4 times the square root of 6, or 2 times the square root of 6.
All right. So we get 6 times the square root of 6. Now, our question for number 2 is a little trickier because we have a square root in the denominator. And you're not allowed to have a square root in the denominator. That's not proper. And we care about proper. So, what could I multiply the numerator and the denominator by that would get rid of that square root in the denominator?
Square root.
So we're going to multiply by 1 in the form of square root of 2 over square root of 2. So what is 2 times square root of 2 times the square root of 2?
1 or 2.
It's 2, because the square root of 2 times the square root of 2 is equal to square root of 4, and the square root of 4 is 2, so that makes sense. And we're still left with 6 times the square root of 2. Now, is it possible to reduce this fraction any further?
No.
We have a 6 in the numerator and a 2 in the denominator.
Oh. Yes.
All right. So how many times does 2 go into 6?
3.
So we get 3 times the square root of 2. All right. So, do you want to work on this one by yourself or do you want to work in pairs?